I'm going to explain about Liskov substitution principle in this video and why it is important and why should we follow. Without any further delay, let's get into the topic. The Liskov substitution principle states new derived classes just extend without replacing the functionality of the old classes. In other words, instance of child class must replace the instance of parent class without affecting the results that we get from the instance of a base class itself. This helps in achieving robustness and easier code maintenance. The most important thing that we should be aware is that the client components should never know which component they are accessing or calling. Let us explore this using our code. If you look at this code, we have defined the interface iRectangle with 4 abstract methods, one being setLength, which will set the length of the rectangle, the other will set the breadth of the rectangle, and the third one will calculate the area, and finally the last one will calculate the perimeter of the rectangle. Now let us move into the implementation of this rectangle logic. The rectangle class implements iRectangle interface. As soon as the rectangle gets initialized, we are going to invoke the setLength and setBreadth methods to assign the length and breadth parameters that were received from the client. The calculate area will return the length into breadth, and similarly the perimeter will return 2 into length plus breadth, which are formulas of the area and perimeter of the rectangles. Now let's look at the client code. For the time being, I'm going to comment out the square implementation. Let's run this. You could see we have provided the length of the rectangle as 4 and the breadth is 2. And if you look at the area of the rectangle, its length into breadth, that is 8. And when it comes to the perimeter of the rectangle, 2 into length plus breadth, that is 2 into 6, that would be 12. That is fine. Now if we want to implement the square, so what I will do for the square, I need not define an interface for the square, because square is nothing but it is a rectangle whose length and breadth are equal. So what I will do is I'll go to the square class, and what I do is when the square is initialized, I'll invoke the parent by providing the length and breadth as same. So what we are doing here, we are substituting the square with the definition of rectangle. If you observe carefully, square is the subtype of rectangle, and what we are doing is we are simply substituting this with the implementation of rectangle without making any changes. Now let us look at the client code. I'm going to uncomment these lines. I'm going to provide the length of square as 4, and now run this code. If you look at the area of the rectangle whose length is 4 and the breadth is 2 is 8 as discussed earlier, and the perimeter is 12, whereas the area of the square is 16, that is length square, that is 4 into 4, and similarly the perimeter of the square is 4s or 4l, so 4 into 4 is 16. So if you look at this implementation, we haven't done anything except the substitution. So this is called Liskov substitution principle. As long as they are subtype of a parent class, we need not define something specific to the derived class. One other important point here is that the client will never get to know which class they are accessing if they are accessing the information from the interface, because we'll get the same results even via rectangle implementation. Suppose if I give the length is 4 and the breadth is 4 and execute this, you could see the area of rectangle is 16, perimeter of rectangle is 16. Similarly, area of square is 16 and the perimeter of the square is 16. So it is exactly same. So why do we need this Liskov substitution principle? Because we need not end up writing unnecessary code. That is the main intention of Liskov principle. One other very important criteria is that the derived class should never deviate from the functionality of the base class. Just it has to extend the base class by adding further more functionalities, but it should never move away from the main purpose. If you look at this code, you could see the area is being calculated as length into breadth. Instead of calculating area in the calculate area module of your derived class, if you are just printing, or maybe if you are just returning some text value which is irrelevant in this context or maybe irrelevant to the functionality, then you are set to deviate from the Liskov substitution principle. I believe this clearly explains what is Liskov substitution principle. If you have any queries, please feel free to mention in the comment section and I will definitely answer your queries. Thank you for watching. Have a nice day.